Hello, this is Pete Cacciopi. I'm Chief Scientist at Optilytics, and this is the second in a two-part video series demonstrating Jupyter-style notebooks being run from within the Optilytics cloud platform. So the notebook that we're reviewing today is the SOTA Promotion Notebook. If you go back to the previous video, I talk about where this notebook comes from. It was developed for a optimization and machine learning webinar that Optilytics presented with Gurobi, and you can download this notebook and the associated data from the TICDAT example page. If you're interested in all that, please see the previous video. So where the previous video left off was right here, prediction in hand, we commenced optimization. So let's walk through. Again, I'm not going to go deeply into the mathematics here. All I'm showing is how an IPYND file, a standard notebook that can otherwise run offline against Excel data. I'm showing how that notebook and that data can be loaded into the cloud platform and run on cloud served data from within the Optilytics cloud platform. So in terms of these equations, I'm not going to discuss the mathematics here. I'm just showing you how these equations are actually LaTeX, so you can type in LaTeX in a cell of an Optilytics cloud platform notebook, execute that cell, and get a nice block of equations. So these cells here are just the same, just setting up the optimization model. So again, we discussed this in detail. There's a video on the Gurobi webpage where we discuss the logic of this code in detail and explain how we're setting up the optimization. And more boilerplate. Okay. And right in here, this is where we're first importing GurobiPy and using GurobiPy to build an optimization model. So to run this notebook on the Optilytics cloud platform, you just need to add a little bit of code so as to access the licensing digital rights management that Optilytics is using with Gurobi. So that's a library from the TICDAT. You can import a function from the TICDAT library. Then when you make your environment, you just set the env variable in the call to model to be the result of calling Gurobi_env. So you don't need to have this line necessarily if you were running this notebook offline, but if you were doing the reverse port, if you were taking an Optilytics cloud platform notebook and then saving it as an IPYNB file and running it in the Jupyter server, you could leave this line here, because for a normal TICDAT install, Gurobi_env just returns the env object from the Gurobi that's part of GurobiPy. So this is sort of harmless if you do this outside of the Optilytics cloud platform, and if you create models this way within the Optilytics cloud platform, then you pass the Optilytics Gurobi licensing. So if you omit this argument inside a notebook, then you'll get an exception throw that'll give you a message explaining that the licensing has failed. So hopefully this should all execute now. And it executed without exception. So again, we're walking through the logic. So these calls to model.update are no longer needed in the most recent versions of GurobiPy, but this code is kind of backwards compatible for older GurobiPys. And here we are finally performing the trying to maximize the aggregate sales. And this looks like a fairly consistent result. And model status is optimal. So doing a sanity check on the solution. Again, I'm not, these are the same results I showed in the webinar, so there's videos for that already. I'm just demonstrating that this all reproduces inside the Applelytics Cloud platform. Here where we have to, this is where we're doing our random seed. We're using, essentially we're using machine learning to perform a simulation on 100 different, doing 100 different simulations of how our optimal plan will play out under a range of scenarios. So this one might take a little while to run. So yeah, bear with me here. I forgot how long this typically takes. So while that's running, I'm going to go down here, edit this code slightly. So because again, we need to change how we show grid results, how we show matplot results. So I'm going to turn these into a series, this data object into a series of dicks. Oh, it looks like that finished. How long does that take? 51 seconds, that's not bad. So we have a series of ticks here for each of these data objects. And instead of calling plot.show, remember the trick here, hopefully the IntelliSense will work and remind me what to call. You say data equals show matplotlib. You pass that plot, right? So now this data, instead of being a set, we're going to have a dictionary that maps these different types of KPIs onto different plots, right? And then, so let's execute that. This should go fast. And it did. So let's show all those plots. So this is a little nicer than Jupyter. You can insert cells above or below. Let's say data. Oops. Data sales. Let's say cell below. Data revenue. See, the IntelliSense is smart enough that it can complete this data indexing. Okay? When I say data, when I put the string in there, I start typing in investment. It knows what the keys are to data, so it makes it easy for me to complete. Let's execute those 3 cells, and we should be able to get visual results here. Here's the histogram for sales. Here's the histogram for revenue. And here's the histogram for investment. Okay, that's the entire notebook. So thank you for your attention, and I hope you will join us for other Applelytics and Applelytics Gurobi videos.